It's slow, but it's not that slow. It's actually decent. So you have the inequality 8x squared is greater than 2x. With this one, you also approach it as a quadratic. You want to put the trinomial on one side of the operator. This symbol here is called an operator. So I can take the 2x to the other side. I get 8x squared minus 2x is greater than 0. Now, how do you solve an inequality? You must always find the critical values. The critical values are the values where this, in this case, it's a binomial, are the values where that function would do with these two terms, this function, 8x squared minus 2x, you want to find the values where it equal to 0. That's what you want to do. That's not going to give you the solutions. It's just going to give you the critical points, which basically lead to your answer. So we solve this equation. We're going to pull out, to solve this equation, you pull out highest common factor of 2x, because that's the highest common factor. I'm going to get 4x here. I'm going to get minus 1 there. Once again, two things multiplying equal to 0, set each of those to 0, and then you get equations. 2x equals 0, or 4x minus 1 equals 0. Then I'm going to get two answers here. X is equal to 0. This pen looks a lot better, by the way. And then I get x is equal to 1 over 4. Those are the critical values. This is a happy phase parabola. So that means I have a happy phase parabola. These are the points. Remember, this is where I set the function equal to 0. Those are like my roots. We call them roots in maths. Those are the points where the function crosses the x-axis. And those are the 2 points. This one here and that one there. The one is going to be when x is 0. The other one is going to be when x is 1 over 4. And this graph is a graph of 8x squared minus 2x. What is this inequality saying? This inequality is saying we're looking for where 8x squared minus 2x is above 0, greater than 0. The 0 line is always the x-axis. The 0 line of any function is the x-axis. This is the 0 line of any function. So when they're saying this is a line x equals 0. I mean, this is the line y equals 0. It should be y equals 0. And this then is saying, this inequality is saying, where is this function above that line, above y equals 0? Because this here, this 0 here represents y equals 0. So they're saying, we want to know the x values where the function is above the y equals 0 line, above the x-axis. Well, here's the part that people struggle with, and I hope to not to get you to be on board. So if I look at this parabola, when it's stretching towards the left this way, if I go to the left of the point x equals 0, the parabola is stretching that way. If I go to the right of the point x equals 1 over 4, the parabola is stretching that way. And these are the parts that are above the y equals 0 line. This part here is under the line y equals 0. That would be less than 0, so that's excluded. So we want to know, what do the values of x look like for the parts of the function above the 0 line? And for this one, we know it's all the values to the left of x equals 0. With this one, we know it's all the values to the right of x equals 1 over 4. So we write it like this. Values to the left of x equals 0, so those are values of x smaller than 0, that's to the left. Or x values to the right of x equals 1 over 4. You can say x is greater than 1 over 4. I use a union symbol. X is less than 0, union, x is greater than 1 over 4. You can also simply write this like this. That's one interval for x values less than 0. That means values to the left of x equals 0. And you can also write x greater than 1 over 4, which means values to the right of x equals 1 over 4.